Hi, this is Leetcode question, smallest missing non-negative integer after operations. This is the last question of weekly contest number 337. In this example, mix equal 4, which is the maximum mix. Mix is the smallest missing non-negative integer. In this example, it's 4. After doing this operation of addition or subtraction of the value 5. Now, how can we solve this problem? First of all, let's take some value like 7. Now, what we can do with value is either add or subtract. So 7 plus 5 equal 12, 12 plus 5 equal 17, plus 5 22, and so on. 7 minus 5 is 2, 2 minus 5 is negative. Now notice that for all of these positive value, the value mod 5 is the same, so 2 mod 5 equal 2, 7 mod 5 equal 2, 12 mod 5 equal 2, 17 mod 5 equal 2, and that means we only need to store this mod value for value 7, and whatever value we want to reach, we can use this mod. So for 7 we will store 7 mod value 5 equal 2 into a dictionary, which is map this dictionary of mod, which is 2 plus plus equal 1. So we store this mod into the dictionary. Let's take another example. 1 plus 5 6, plus 5 11, plus 5 is 16, and so on. 1 minus 5 is minus 4. Notice for all of these values, the mod of value equal 1. So 1 mod 5 is 1, 6 mod 5 is 1, 11 mod 5 is 1. So we store of 1, we increase it by 1. For minus value, minus 10, plus 5 is minus 5, plus 5 is 0, then 5, then 10, and so on. And the mod for this value is 0, 0 mod 5 is 0, 5 mod 5 is 0, 10 mod 5 is 0. So in the dictionary we store of mod, which is 0, equal 1. We increase it by 1. Now notice that we calculated this value 0 for the minus using this operation, so which equal the value, in this case it's 5 minus absolute value of 10 of minus 10 mod 5, and this equal 5 minus 10 mod 5, and this equal 5 minus 0 equal 5. And here again we do mod, so 5 mod 5 equals 0. So at the end, for minus value, the mod we want is 0, because minus 10 plus 5 is minus 5, plus 5 is 0. So at the end we reach these positive values that has mod equal 0. And now for positive values we directly take the mod. Since for example 7 mod 5 is 2, so we store 2. Now if we have another negative value like minus 9, so minus 9 plus 5 is minus 4, plus 5 is 1, plus 5 is 6. And for this positive number, 1 model 5 is 1, 6 model 5 is 1, 11 model 5 is 1. How can we get the 1 from minus 9? Again, we will do this operation, which is here in this code, using the value 5 minus this absolute value of minus 9 mod 5. This is 5 minus 9 model 5, which equal 5 minus 4. This is equal 1. 1 model 5 is 1, and this is what we need. But minus 9 is not presented in our array. Next element is 13. Now 13 plus 5 is 18, plus 5 23. 13 minus 5 is 8, minus 5 3, minus 5 minus 2. Notice that for the positive values, these all have the value 3. 23 model 5 is 3, 18 plus model 5 is 3, 13 model 5 is 3, 8 model 5 is 3, 3 model 5 is 3. So we simply store 13 mod L5 equal 3. Since it's not in the dictionary, of 3 equal 1. And for 6 plus 5 is 11. 6 minus 5 is 1. So all we need to store is the value 1, which is 6 model 5. Since all of these value model 5 equal 1, so here m of 1 equal 1, we add another one, which is 2, and that means that we have two numbers and nums that has mod equal 1, and from this mod we can reach any value plus 5. So 1 plus 5 6, plus 5 11, and so on. Then we have the value 8. So 8 minus 5 is 3, plus 5 is 13. The mod for all of these values is this value 3, and that means we increase this counter by 1. So this is our final dictionary that contains the count for all the mods. M of 2 equal 1, M of 1 equal 2, so we have M of 2 equal 1, M of 1 equal 2, M of 0 equal 1, and N of 3 equal 2. That means there are two numbers with mod equal 3, and from 3 we can reach any numbers with addition, like 3 plus 5 plus 5 plus 5. Now what we need to do is incrementally we need to check if we can cover numbers from 0 up to n. N is the number of values here, 1 2 3 4 5 6. So can we cover the number 0? And we need to check here if we have count 0. The answer is yes, since m of 0 equal 1, so we can cover 0. And we decrement this by 1 because we used that one to have this value 0. And this was this value minus 10. We use it to reach the value 0 by adding 5 twice. Then the for loop, next we need to check for if we can have 1. M of 1 is 2, so yes, we can have it. We decrement by 1 since we use one number to reach 1, and this number could be this one itself. Then can we reach 2? The answer is yes, m of 2 equal 1, so we subtract, this is 0 since we used one number to reach the value 2, and this number could be 7 since 7 model 5 is 2, and we can reach 2 by just doing 7 minus 5. Now next, can we get the number 3? The answer is yes, so 2 minus 1 is 1, and indeed we can reach 3 using numbers like 13, since 13 minus 5 is 8, 8 minus 5 is 3. We can reach the number 3, and that's because also 13 model 5 is 3. Now can we reach 4? The answer is no, and that's because m of 4, there is no number that can lead us to 4, so directly we return 4. Notice here, while checking, we check if I model value exists. So assume if we have if 4 can reach it, then 5. Then we don't check here for 5, but we check for 5 model value, which is 5. That's 0. Since to reach the value 5, it's the same as to reach the value 0, because if we reach 0 we can just add 5. And for 6, we check for 6 model 1 in the dictionary, 6 model 5, which equal 1, so we check for 1. But in this example we couldn't reach 4, so we just return the value 4, and indeed this is the answer for the example.